Welcome to Projects M Squared and M Cube, Verbal Communication in Mathematics. Mathematical thinking and learning are deepened and enhanced by activities in which students and teachers talk, write, and use mathematical symbols together, while working hard to convey and clarify their mathematical ideas. This webinar addresses the talking or verbal communication that is an integral part of both mentoring young mathematicians and mentoring mathematical minds. My name is Valerie Josie. I have 31 years in the public school system, 21 years as an elementary classroom teacher. After that, I served in the curriculum office as a math coach, as the professional development school facilitator working with pre-service teachers and with first-year teachers, and as the elementary math coordinator. I began working with Project M Squared, a primary mathematics program, in 2008, and the move to include Project M Cube was a natural fit. Both M Squared and M Cube were written and developed by some of the same authors, with basically the same goals and strategies used in both programs. Since my retirement from the public school system in the state of Texas, I have worked as an elementary math consultant, sharing what I have learned about teaching math in programs that include all of the best practices and make math something real and fun for both children and teachers. The benefit of verbal communication can be substantial for both students and teachers. When instruction includes planned time to discuss different strategies and confusions that may arise during discussion, students can learn from what others are thinking. Although arriving at the correct answer is a goal, the processes that students use along the way should be a major focus. There is more to success in mathematics than just saying the correct answer. Understanding and valuing complex ideas and arguments that were once foreign to them can come from effective communication. In addition, students may sometimes find errors in their reasoning when they try to explain their ideas verbally. A student may try to find the words to support his thinking, only to find that he can't because it does not make sense at all. Teachers can also benefit from verbal communication. By providing time for students to discuss and express their thinking, teachers gain a better understanding of what students do and do not understand. The teacher can then adjust and focus his or her instruction accordingly. Many teachers have said that they also gain a deeper understanding of how students learn mathematics by listening to them trying to explain their thinking. Now that you can see the importance of verbal communication in the math classroom, let's look at how Projects M Squared and M Cube are structured to help promote discussion that nudges student thinking forward. Our agenda covers both Project M Squared, designed for kindergarten through grade 2 students, and Project M Cube for mathematically talented students in grades 3 through 6. We'll look at the speaker and listener roles in Project M Squared. These lead into the classroom discussion rights and obligations introduced in Project M Cube. Then we'll delve into the talk moves used in both programs and follow that with 5 W's and an H. The Center Discussion Guide is a simplified version of the same thing. To wind up, we will close with building a bridge from verbal to written communication by looking at the talk frame in Project M Squared and the math messaging board in Project M Cube. So, let's get started. Primary students do not necessarily know how to communicate in mathematics, so teachers need to help students learn what this means. Each grade level uses intriguing characters that are introduced in the introductory lesson for students to communicate with throughout the units. You can learn a bit more about these characters in the Project M Squared webinar. Also introduced in the introductory lesson are the speaker and listener roles. Since students are more likely familiar with speaking, the speaker's roles are presented first. These address the ideas that speakers need to be heard across the room, that the speaker should be the focus of everyone's attention, speakers share different ideas and explain them, and that the focus is on the mathematical validity of the ideas rather than the person who shared it. Of course, the wording is appropriate to the children's level. While most children understand that they are supposed to listen to the teacher, they need to learn that it's also important to listen to their peers' ideas. They also need to learn how to listen. The listener roles empower students to ensure that they can hear others' ideas. The roles guide them to demonstrate through body language that they are listening. The focus should be on listening to try to understand and make sense of everyone's ideas. We want the spirit of inquiry and an environment that fosters respect for each other and each other's ideas also present in the elementary classroom. Therefore, the teacher is the key to setting the stage in establishing a mathematically vigorous environment respectful of all its participants. The classroom discussion rights and obligations lists expectations for these particular behaviors. All students and teachers have the right to ask questions. They have the right to make a contribution to an attentive, responsive audience. They have the right to be treated respectfully, and the right to have your ideas discussed, not you. They have an obligation to speak loudly enough for others to hear, an obligation to listen to others in order to understand, and they're obligated to agree or disagree with the speaker's comments and explain why. Like the speaker and listener roles, these expectations apply to all disciplines and can be used throughout the school day. Talk Moves, adapted from Chapin, O'Connor, and Anderson's books, is an approach that facilitates discussion and gets students to think mathematically. We want to focus students' attention on the central mathematical ideas as they consider them in depth. These moves help move the conversation away from teacher to students and then one student directly back to the teacher. We move more to a discussion among the teacher and all students, including student to students. The teacher is helping students make sense of the ideas expressed. The first talk move we will explore is revoicing. In revoicing, the teacher restates a student's idea and then verifies whether it was an accurate interpretation. For example, a teacher might ask, "You said that the area is 24 square inches?" This move can be used when a student's response is unclear, to highlight a student's brilliant response and set the stage for discussion so students can think about it a bit more, and it also allows students to clarify their thinking. Let's listen in to part of a discussion in a Level 3-4 classroom. The class has been looking at patterns and explaining them using the properties of equations and solving problems involving multiplication and division. Students were given this problem. Sarah was really bored one afternoon and wrote her name 50 times. What was the 137th letter that Sarah wrote? Explain your thinking. Max, can you explain how you figured out the 137th letter that Sarah wrote?
Well, I wrote Sarah's name 50 times to find out the right letter. It took lots of work and took me a long time. I think the letter was the letter A.
Max, you're right. You could write Sarah 50 times and then count all the letters until you reach the 137th letter. I'm sure it did take a long time to write it out. Can anyone think of an easier way to do it? Yes, Jack.
I don't think you have to write Sarah's name 50 times. I think you need to find out how many letters are in Sarah's name first. Remember when we looked for a pattern when the teacher wrote the letters Sarah had doodled on the board? We looked to see when the name started again. We used the same letters in the same order. I think we need to look at the pattern too, so we know when the pattern repeats.
Well, Jack shared some thoughts that are important. Can someone share those again in his or her own words? Yes, Campbell.
When Sarah was repeated in the doodle, we looked to find what the next letter in Sarah's name would be that she scribbled. Her name was our pattern. That means the number of letters in her name lets us know when her name will begin again. See, her name is 5 letters long, so the 6th letter will be an S. You have to keep the letters in the same order.
How can we use our thoughts about patterns to find the right letter in the sequence? Talk to a partner and share your thoughts. We'll come back together in a few minutes to share our ideas. Can someone share their ideas? Yes, Simon.
Well, Tim and I decided that if we took the number of letters, which is 5, and divided 137 by 5, we could find out how many Sarahs there are in 137 letters. We could name Sarah 27 times, which is the same as 135 letters. So S would be letter 136, and an A would be letter 137.
What if the name that we doodled was Giovanni? How can we find out with the 137th letter if Giovanni doodled his name? Did you hear the teacher revoicing Max's answer? The teacher asked, "Max, can you explain how you figured out the 137th letter that Sarah wrote?" And Max responded, "Well, I wrote Sarah's name 50 times to find the right letter. It was a lot of work and it took me a long time. I think the letter was the letter A." The teacher is revoicing when she says, "Max, you are right. You could write Sarah 50 times and then count all the letters until you reach the 137th letter. I am sure it did take a long time to write it out. Can anyone think of an easier way to do it?" Yes, Jack. The next talk move is repeat and check, very similar to revoicing. In repeat and check, the teacher asks other students to restate an idea and then follows up with the student contributing the original thought to ensure that the idea was heard as intended. For example, the teacher asks a student, "Can you repeat what James said in your own words?" The student responds, and then the teacher goes back to James and asks, "Is that what you said, James?" Repeat and check is used to validate the student's idea, to encourage students to listen rather than just hear what others are saying. It gives the class another version of the idea, time to process it, and it makes certain they're following the conversation. Repeat and check also helps students engage with the thinking and reasoning of others. Our sample dialogue here is from the kindergarten unit, Sizing Up the Lily Pad Space Station, Measuring with the Frogonauts. In this lesson, students come to understand that linear measurement is an accumulation of standard equal length units laid end to end with no gaps or overlaps. Students are presented with this question from Fonzie. "I am confused. I measured and got different answers. This is what I did." There are 4 pictures showing the different ways that Fonzie measured. Students are to circle the right way to measure and then explain why 2 of the others are wrong. Here's part of a small group discussion about the question. Can you identify, repeat, and check? Which answer do you think is correct? Shelby?
I think it's D. He went all the way across.
Do you agree or disagree with Shelby?
You can't put one on top of the other.
Yeah, they have to touch, but not be on top.
Can someone repeat what Paul and JC just said?
I think that they said you can't overlap.
Paul and JC, is that what you said?
Yeah, B is right, because the bullfrog sticks don't overlap.
What do you think of this idea? Do you agree or disagree that B is measured the right way?
I think it is B too.
Why?
Because they have to be the same size, and you have to line them up straight. It can't be C.
Sophie's brought up another idea. What do you think about how Fonzie measured in C? Talk to your partner about if you think he did it the right way or not, and why. Did you hear the repeat and check talk move? The students were discussing which answer was correct. Paul said you can't put one on top of the other, and JC said, yeah, they have to touch but not be on top. The teacher then says, can someone repeat what Paul and JC just said? Michaela says, I think that they said you can overlap. And the teacher comes back with Paul and JC, is that what you said? The third talk move, adding on, prompts students to further participate. The teacher asks students to expand upon the idea already stated. For example, the teacher may ask, "What can you add on to Marty's idea?" The purpose of adding on is to validate original ideas, to make original ideas more comprehensive, to allow for more perspectives to be considered. It helps students engage with the reasoning of others, and it also extends thinking to include new ideas. Now we're going to listen to part of a discussion in a classroom where students are learning about decimals. This comes from the Level 4-5 unit, the 10th Street Pet Sanctuary, Understanding and Using Decimals. This is Lesson 2 from Chapter 1, in Parrot Talk, A Weighty Matter. The lesson has students comparing and ordering decimals and building an understanding of the density property of decimals. At the end of the lesson, students are presented with this question. Pinky and Lemon Drop are budgies and playmates of Sky. Petra forgot to record Sky's weight on Tuesday on the chart. Liz said Sky's weight is between Pinky's and Lemon Drop's weights. Use the Pretty Bird's weight and length chart to name 3 possible weights for Sky and explain your answers. Here's part of the classroom discussion. Listen for the add-on talk move.
Estelle, you just said that you used the budgie weights of 26 grams, 26 and 1/10 grams, and 26 and 1200 grams. Can you explain how you decided on those numbers?
Sure, all of the budgies had weights that began with 26. So I started with 26 as one of my endpoints and I used 27 as the other.
Can someone agree or disagree with Estelle's answer and tell why?
I am not sure that is just right. I know that all the numbers start with 26, but I think we have to worry about the decimal places as well. If we are looking between just beginning numbers, the next number is 27, so she's right there. But I think we have to look at the decimals to find numbers between.
So Phoenix, are you saying that when we use whole numbers, we cannot find any numbers between, but we can if we use decimals with whole numbers? Is that correct?
Oh, Phoenix, I see what you mean. If you look at the decimal numbers, they start the same way, but the decimals show us that the number is bigger than 26, but not 27.
Michael, can you add on to what we're saying by using an example? Come up to the board and explain what you mean.
Well, see, Lemon Drop is 26 and 83 hundredths grams. And see, there are tenths and hundredths after 26. So she is more than 26 grams, but not 27 grams, and neither is Pinky.
Class, how many decimal numbers do you think we can put between 26 and 27?
Well, I think there must be lots of them. We have learned about decimals that were written in tenths, hundredths, and thousands. So I think all of those can be used. I think if there were more decimals names too, we can keep on writing whole numbers bigger by adding more places. I think that we can do that with decimals too.
So I can make lots of decimals. What was that rule you talked about with decimals and fractions? I think it was a property or something.
I think Phoenix is onto a good idea. It is named the density property of decimals. Talk with your partner and let's see if anyone can remember what that property is all about.
Add on. Did you hear it? The teacher asked Michael, "Can you add on to what we're saying by using an example? Come up to the board and explain what you mean." And Michael responds, "Well, see, Lemon Drop is 26 and 83 hundredths grams. And see, there are tenths and hundredths after 26, so she is more than 26 grams, but not 27 grams, and neither is Pinky." Agree or disagree and why is used after the teacher makes sure that students heard and had time to process their thoughts. After the topic of discussion has been established, the teacher has students analyze and defend their positions using mathematical reasoning. The teacher poses a question such as, "Do you agree or disagree with that idea? Why?" By doing this, the teacher draws out student thinking by having them apply their understanding to someone else's thoughts. Other benefits of using the agree-disagree talk move are that it furthers understanding and addresses misconceptions. It assesses students' current level of understanding. It can clarify and deepen reasoning, and it allows students to grapple with their thoughts. This sample discussion is from the Level 5-6 unit, Designer Boxes, Exploring Volume and Surface Area. Students have investigated rectangular prisms by identifying the dimensions, understanding that volume is measured using unit cubes, discovering the layering approach, and connecting it to the formula for the volume of a rectangular prism. Here's a Think Deeply question for this lesson. What is volume? How can you find the volume of a rectangular box? And part B, does your method work to find the volume of all rectangular boxes? Why or why not? And here's the discussion. Listen for the agree, disagree, and why talk move.
Let's talk about finding the volume of a rectangular box. Leslie, can you explain your method again?
Sure. I first found the number of cubes in one flat layer.
What do you mean by a layer?
Well, see, you can take this box apart and make layers. You can take a box apart in different ways into layers. Lai has another box apart in layers.
You can put these together like this to make the box.
Okay, thanks. So Leslie, now that I understand what you mean by a layer, how did you find the number of cubes in a layer?
I just counted them up.
You can also multiply.
Noni, can you elaborate a bit on what you mean?
If you multiply the length and the width, you get the number of the cubes in one layer.
Ben, can you restate what Noni said?
The number of cubes in a layer is width times length, or 32 cubes. You can also multiply length by width.
Do you agree or disagree with Noni and Ben's idea? Talk to your partner for 1 minute about this. Okay, Aaron, what did you and your partner discuss?
When you multiply the length by the width, you get this layer. You could count, but it is faster to multiply and it is easier. If it is a rectangular box, the layer will fit in the bottom. Right, Kim?
Yeah. See? If you multiply two of the dimensions, you get a layer. It doesn't matter which layer, as you can turn the box to have that layer fill up the bottom.
I see. When we multiply the dimensions, length and width, you get the number of cubes in a layer. Turn to your partner and explain this in your own words to each other. Now, what do we do next to find the volume? Kanano?
You multiply the number of cubes in one layer by the number of layers, like 2 here.
Can you say a bit more about that?
The box goes up by layers. Its height is how many layers, so you multiply. That is how you know it is filled up to the top.
This one's easy to identify. The teacher clearly asks, do you agree or disagree with Noni and Ben's idea? And then when the students answer, they do explain why. Think time, often called wait time, is when the teacher waits to call on students after a question has been posed. Wait time is also the time given to a student who has been called on to respond. An example of wait time is for a teacher to call on a student. The student does not respond, and the teacher says, "We'll wait for your idea." Wait time serves several purposes. Wait time gives students time to process and organize their thoughts. It sends the message that students' reasoning is valued. It allows for informal assessment of student understanding, and it encourages all students to participate. To illustrate wait time, we'll listen into part of a discussion from another Level 5-6 lesson. This one comes from Record Makers and Breakers, Chapter 2, Lesson 4, Set Your Own Record. Students have investigated analyzing change in situations through graphing and looking at the relationships between variables. slope, y-intercept, and points of intersection are all examined. This question is from the final lesson in the unit. How do you know if your scenario involves a linear relationship? That is, how can you tell when the points you graph to illustrate your scenario will all lie on the same line? Use tables, equations for both recursive and explicit rules, and graphs in your explanation. Listen for the wait time.
How can you tell by looking at data on a table that if you graph the points from the table, they will all lie on the same line? Serena,
I look at the table to see if both columns go up the same.
could you repeat what Serena has said? Rajiv,
Serena said that numbers in both columns should go up the same. I guess that means that if one goes up by 5 every time, the other one also has to go up by 5 every time.
is that what you mean, Serena?
Yeah, I guess so. Is that right?
What do the rest of you think?
I don't think that they both have to go up the same, just so they both have to go up regularly.
Could you explain that more, Dorsey?
Well, one column might go up by 5 every time, but the other column could go up by a different amount each time, like 10 or 15 or 1. That would still make a line.
I want you each to talk to a partner about how you can tell whether there's a linear relationship among the points illustrating your scenario. Also, talk about how this affects your equations for explicit and recursive rules. We will talk about this further after you talk to your partners for 2 minutes.
Did you hear the wait time? Were you able to identify it? The teacher says, how can you tell by looking at data on a table that if you graph the points from the table, they will all lie on the same line? Serena. Another example. Could you repeat what Serena has said? Rajiv. Notice that the teacher used the students' names after posing the questions. The last talk move we'll cover today is partner talk. Partner talk is simply that. Students are given opportunities to discuss their ideas with a partner before participating in the class discussion. The teacher says something similar to, turn to your partner and talk about, and then she names a specific topic. Why is partner talk used? Well, it gives all students a direct audience. It possibly provides a safer environment to share tenuous ideas. Partner talk begins to work out undeveloped ideas, and it gives students an opportunity to listen to another perspective. This time, the sample dialogue is from the Level 2 unit, Shopping at the Bazaar, Connecting Number and Algebra with the Meerkats. The lesson objectives address equality, developing strategies to solve addition equations, using variables, and the associative property. Here's the think deeply. Explain to Drew and Teller how Suma can easily figure out the number of agate stones to put in the bag when given the following equation. 246 plus box equals 319 plus 248. And part B, use words, numbers, pictures, or diagrams to show that both expressions are equal. Listen for the teacher using the partner talk move.
Karina, tell us what you and your partner talked about to find the number of missing agate stones in the bag.
We first looked at the equation and saw that there was 246 on one side and a 248 on the other side.
What do you mean, a 246 on one side and a 248 on the other side? Sim, can you explain?
See the equal sign in the middle? The 246 is on one side of the sign, and the 248 is on the other. They are close.
And why is it important that we think about these two numbers in the equal sign? Talk to your partner about why Karina and Sim are comparing these numbers. Who wants to share? Aaron?
The two sides of the equation have to be balanced, and that means that both sides have to add to the same amount. Right,
So we can say that 246 plus the square is the same as 319 plus 248.
I'm still confused by why Karina and Sim are comparing the 246 and the 248. Karina?
This 246 is 2 less than this 248. So right now I know that this is 2 less than this.
Famil, would you please repeat what Karina just said?
Karina is saying that 248 on the right is 2 more than the 246 on the left of the equal sign.
And why is that important?
Well, if the expression with the 248 is 2 more than the expression with the 246, then we have to add 2 more to the side with the 246.
Because we are trying to make the two expressions equal.
Let's take a minute and talk with our partners about the words equation and expression. What do they each mean? Practice using these words to talk about what Famil and Liz just said.
This is another easy one to spot. At the end, the teacher says, let's take a minute and talk with our partners about the words equation and expression. What do they each mean? She uses the words talk and partners. That's exactly what's happening. Partners are talking to each other. Now we'll see part of a discussion in an actual first grade classroom. What talk moves can you identify?
In creating the school measurement fair, Measuring with Emmy and Zany, first graders think deeply about the concept of weight. Rather than using units of measure, they compare the weights of objects by focusing on the position of a hanger scale. To make the problem richer and more complex, the teacher has students compare a bag full of cotton balls with one pair of scissors to push students to focus on weight rather than the number of objects.
Could you add to his thinking for me?
Mr. Lane, I'm confused.
You are confused. Why? Explain your confusion.
Because the cotton balls have a lot and the scissors only have one. It doesn't matter what the number.
Oh my goodness, wait a minute. Abel, could you raise your hand for that? Don't forget rule number 3. I heard Yashira say she was confused because there were a lot of cotton balls and only one scissor. Abel, could you help us in our thinking?
It doesn't matter what the number, it matters what the weight is.
Oh, so who could restate what Abel just said to me, Maheshwar?
It doesn't matter what the number is, it matters what the weight is.
Thank you. So, if I'm looking at that then, if I used my word heavy, what sentence could I use if I use the word heavy? Adrian.
The scissors are heavier than the cotton ball.
And macaroni switcheroni, Ziamira.
The cotton balls are lighter than the scissors.
Would you kiss your brains? That was so cool. Good thinking.
I'm sure you heard the dismissal bell, but did you also hear the teacher use the add-on, revoicing, and repeat and check talk moves? She used all 3 in this short video. Now let's move on to another strategy, 5 W's and an H. Just as students answer who, what, when, where, why, and how in language arts, they can answer these same questions as they investigate and extend mathematical problems. As students begin to think like mathematicians, they realize that the most interesting mathematical concepts often begin after they answer the initial question. In Project M-Square, we want students to think about these questions, especially when they're working in their math centers. Teachers have a center discussion guide with sample questions appropriate for primary students. Students using Project M-Cube units are encouraged to answer the same questions. Some sample questions for each of the 5 W's and an H are: who? Who has another method? Who has another solution? What or what if? What sense can I make of this problem? What is the answer? What is the important mathematical concept? When? When does this work? When does this not work? Where? Where did that come from? Where should I start? Why or why not? Why does that work? If it doesn't work, why not? How? How is this like other math problems or patterns that I've seen? How is it different? Additional suggestions for questions can be found in the teacher guides. It can be challenging for both teachers and students to keep track of all that has been said during a discussion. Teachers using the Project M² units use a talk frame to keep track of student contributions and revisions to their ideas. The talk frame is a system that helps teachers organize and maintain a more permanent record of the conversation on the board. A talk frame consists of 3 parts: think, talk ideas, and we understand. Think establishes the topic. When using the talk frame with the Think Deeply question, I have students restate the question in their own words. Talk ideas are brief statements of students' ideas. Both correct and incorrect ideas are recorded. These ideas may be refined as students discuss and clarify their ideas. This is an opportunity to gather different student perspectives. We understand? In this section, the teacher guides students to reach a mathematical understanding. Students often notice the errors in their thinking, given time to discuss and justify their ideas. The talk frame becomes the bridge from verbal to written communication. Much like the talk frame in Project M², the Math Messaging Board is the connection between verbal communication and written communication in Project M³. Using the Math Messaging Board, teachers record conversations, especially those that center on the important mathematical ideas of the lesson. Since students are expected to write about these ideas, documenting the conversation helps solidify student understanding. The Math Messaging Board consists of 4 parts: talk about it, keep a record, wrap it up, and write about it. Talk about it is what the class will discuss. Here again, students restate the question in their own words. Keep a record is where each new idea that students bring up in the discussion is written down as bullet points. This section is meant to be notes that give students a reference point to begin writing their Think Deeply responses. Wrap it up signals a discussion that encourages consensus and mathematical understanding. Write about it. It's now time for students to write their Think Deeply responses in the Student Mathematician's Journal. This is the final link connecting the talking and the writing. For more information on using the talk frame and/or the Math Messaging Board with written communication, view the webinar on written communication. Remember, a rich mathematical discussion should include challenging and thought-provoking questions, as Think Deeply certainly are. It should include an environment that is respectful of the thoughts and ideas of others. The speaker and listener roles, as well as classroom discussion rights and obligations, help achieve this. A rich mathematical discussion should be a skillful facilitation to keep the focus on important mathematics. Students' conjectures, strategies, reasoning, and justification are evident, and students are learning from one another. The talk moves, the 5 W's and an H support these descriptors. These are the things that make verbal communication effective communication. Now that you're aware of the verbal communication strategies used in both projects M² and M³, look at a brief discussion in a Level 1 classroom working in the measurement unit.
The Project M Squared units encourage students to communicate like practicing mathematicians and engage in high-level discussions about important mathematical concepts.
And we also have for teachers talk moves that help them figure out how to facilitate these high-level discussions. And generally what they do is, help students make sure that they're clear in what it is that they're saying, practice and use the language of mathematics so that they can be more precise in their language, ensuring that the rest of the class is actually considering these individual ideas. But then the meaty part comes. It's when students are able to grapple with the mathematics and really take on the role of a professional mathematician to reason about the mathematics and come to a mathematically valid conclusion.
This all takes place within a supportive environment that has students take on respectful speaker and listener roles. This can be seen in this lesson that has first graders contemplate where numbers should be placed on a ruler they've begun to build in order to deeply understand the conventions of this measuring tool.
What's missing from this ruler that real rulers have? Emma?
The inches.
The inches. Who can add on? Inches or Junaid?
The numbers.
The numbers. We have to number our rulers. So where exactly do you think I should write the numbers on this ruler? Jason CE?
Next to the straws and pipe cleaner.
Now, Jason CE is saying next to the straws on the pipe cleaner. Emma, do you agree with Jason CE?
Well, I agree, but I think I have a better way to say it.
Okay.
Under the pipe cleaner.
So underneath the pipe cleaner, and who wants to add on? I think I know what you mean with your word. So in between the straws of the pipe cleaner, underneath. Excellent. Malika?
Could also do it on the bottom, but touching the very bottom.
But touching the very bottom, like down here? Oh. Or instead of like right up against the straw, is that what you're saying? Okay. Rita, what are you thinking?
I would disagree with Emma because that would be more easier to measure, because if you put one here, that would be easy to measure, like the paper or the whiteboard.
So when we're measuring, it's going to be easier if we write the numbers right underneath it? Oh, interesting thinking. Cigar?
Nobody is afraid to speak. They all are excited and share their learning. They really get down to mathematics. They automatically just tell you what their thinking is. They don't have to be asked. And I see them also asking their peers when they're playing a game, why do you think that? Can you tell me more about that? So when you hear them asking the questions that teachers are asking, it's really exciting and shows that their understandings are much deeper than what they used to be.
For more information on Project M Square, you may wish to check the website projectm2.org. And for Project M Cube, the website is projectm3.org.